Welcome to episode 284 of CppCast, the first podcast for C++ developers by C++ developers. I'm your host, Rob Irving, joined by my co-host, Jason Turner. Jason, how are you doing today?
All right, Rob, how are you doing?
Doing okay. Don't think I have too much news to share this week. How about you?
Just a funny aside, you can see I've got this castle behind me, right, which is Eliandonan Castle in Scotland. And apparently Claire McRae noticed this
We've had on the show before.
On one of the recent videos that was posted on YouTube. And I'm aware that this is a castle that's associated with the Mackenzies because that is something to do with my wife's family. And that's one reason we went there. This is a picture that my wife actually took. And Claire pointed out that it's actually the McRae-Mackenzie Castle, apparently. And so she thought it was very interesting that the castle is there.
That's interesting.
Yeah.
Very cool. Okay, well, at the top of every episode, I like to read a piece of feedback. This week, we got a comment from an episode on YouTube. This was our end-of-year 2020 episode. And Falcon wrote, regarding scripting, I'd be interested to see what either of you think about TypeScript on Node or Dino. It's got a ton of advantages of the NPM ecosystem, rich set of packages, convenience of installing, etc. And the language itself has a really good set of features. We've certainly talked about TypeScript several times, including with your cousin who worked on it, but I'm not familiar with TypeScript being used in other languages.
Well, Node is just a JavaScript engine, right?
Right. Well, what is Dino? I have no idea what Dino is.
No idea. Does our guest know? He's smiling.
No.
Oh, okay.
I don't know too.
Okay.
No, but I'm gonna just say I'm fully on board. If you're doing JavaScript stuff with Node, go ahead and use TypeScript, right? Because that gives you an extra level of protection, I guess, or assurance that your code is correct.
Okay, well, we'd love to hear your thoughts about the show. You can always reach out to us on Facebook, Twitter, or email us at feedback@cppcast.com. Don't forget to leave us a review on iTunes or subscribe on YouTube. Joining us today is Klaus Iglberger. Klaus is a freelancing C++ trainer and consultant. He has finished his PhD in computer science in 2010 and since then is focused on large-scale C++ software design. He shares his experience in popular advanced C++ courses around the world, mainly in Germany, but also the EU and US. Additionally, he is the initiator and lead designer of the Blaze C++ math library and one of the organizers of the Munich C++ user group. Klaus, welcome back to the show.
Hi. Thanks for having me back. It feels really good to be back. Yeah.
I can't remember if I asked you about this last time we had you on, but did you specialize in anything in particular for your PhD?
So my PhD was about particle simulations in particular, but it was mostly about high parallelization. So the biggest machine at the time was, so at least in Germany, was about roughly 300,000 cores, which I was able to use at least once. So, yeah.
Nice.
Very cool.
Did you simulate anything interesting in your experiments there?
So the attempt was to simulate as many particles as possible within a fluid. And so I cannot claim that it was particularly interesting. It was a scaling experiment. But later this was used to do something more valuable, I believe.
Well, that kind of thing is always fun, though, when you've made a visualization of the simulation of the fluid particles or something like that.
That would have been fun.
Do you still have the data?
300,000 cores, 2 files. Oh my.
Okay, well, Klaus, we got a couple news articles to discuss. Feel free to comment on any of these, and we'll start talking more about the solid principles and what you've been up to, okay?
Right.
All right, so this first one we have is a post on the Windows developer blog, and this is about making Win32 APIs more accessible to more languages. And obviously, if you're on the Windows platform, you can access the Win32 API if you're using C or C++, but they're trying to create new projections to make it easier to use in C# and Rust. And also, it's kind of mentioned at the very bottom of this post, they're going to make a modern C++ projection of the API. So, instead of using this somewhat ugly C API, you can do it in kind of more native C++, which sounds really nice.
Rob, I feel like you're so much more connected to this kind of thing than I am, but how does this differ from the WinRT or whatever?
I think it is based on it a lot. And when reading this post, I definitely assumed that Kenny Kerr, who we've talked to about with WinRT, and I believe the name of that project was like Modern C++ or something like that, Modern CPP. I believe he's involved with this. Maybe we should have him on again to talk about it. I don't know what else to say.
Okay.
Yeah. Klaus, do you have any thoughts on this one?
So I definitely like the idea, and I do like that they also use the community effort. A couple of people have done this on their own before. And Microsoft is basically collecting this wisdom and trying to move forward, which I feel is indeed a very good thing. I did not use the Win API personally, so for me it's not a direct win. I don't know this either.
No, I haven't. I've used it only when I have to. Load library, for example.
Yeah.
Like I've probably used maybe all told a dozen Win32 API functions.
Well, they mentioned C# here and having to write, p-invoke calls by hand if you want to use Win32 APIs there. And I've definitely done that a couple times. So being able to access those APIs natively with C# would be very nice. Okay, next thing we have is a post on the CPP subreddit, and this is, do people have some motivating examples for coroutines? Jason, you want to go over some of these?
Well, yeah, I mean, I personally, I'm constantly having people ask me, can you do an episode about coroutines on C++ Weekly? And I know I've mentioned it on this show in the past, that the fact that we don't have a standard library for coroutines is a little frustrating. But anyhow, there's a couple of examples here, like someone who wrote a Game Boy emulator that uses coroutines and awaitable types. And that's something that Matt Godbolt and I did a live stream about, discussing what the possibilities were there. We didn't get very far. So for people who are interested, might check that out.
Very cool.
So this is also something I get in my training classes a lot. People asking about real examples, not just the toy examples that you usually see.
Yeah.
So this was pretty interesting, and indeed the Game Boy thing struck out.
Yeah.
There's a few examples in here that I have to agree with some of the other commenters that I'm like, yeah, I'm pretty sure you could just do that with a future, or not. I mean, a promise. I mean, not necessarily a future. You don't need a full coroutine stack here for this example, but I don't know.
Okay, and last thing we have is the first ISO C++ mailing of 2021, the January mailing. And a couple of things stood out to me here. First of all, right at the top is introducing std colony to the standard library. And that one just made me think of, how long we've been doing this show, because I went back and we talked to Matt Bentley, I think it was episode 65, about the PLF library he wrote and the colony container. And I don't recall if he was trying to standardize it as far back as when we recorded that episode.
Oh, no, he was definitely talking about it. If you look at this is revision 12 of his paper.
It's been going on for a while.
It's been discussed a lot in the mailing lists. This one was one of the hottest topics.
Is it coming to fruition? Do we think it's going to make it in sometime soon?
Oh, that I don't know, of course.
That you don't know.
But
okay.
No.
I spent so much time with PMR and custom allocation stuff on the series that I did on my YouTube videos that I have thought back to these colony containers and wondered, could you get basically the exact same thing by just using a monotonic buffer resource behind your list or whatever? And I don't know if that's the case. If that is the case, then I expect someone on the committee would have brought that up at this point, and I should go back and review these things more in depth.
Another interesting one I saw. Go ahead.
Sorry.
No, go
so
ahead.
What struck my eye was the problems with cbegin. I have to admit I wasn't aware of that. That is a paper by Nikolai Yositis, so P2027-6. That I found pretty fascinating. A little detail that interesting how easily things can go wrong. So apparently cbegin did not work well in combination with span. And so the first fix was to remove the cbegin and cend, also member functions from span, which however did not really solve the problem. It even made it worse. Nikolai is now arguing to put them back and to really fix the problem. That was a fascinating read for me.
I'll have to check that out too then.
Yeah.
It was fascinating that he found this out so late, that this little detail apparently slipped through everybody's attention.
Seems to be that happens surprisingly often.
Yeah, unfortunately.
Anything else you wanted to mention here, Jason?
Yeah, the changing scope for lambda trailing return types from Barry, P2036R1, struck me as interesting because if you've spent as much time with lambdas as I have, you would go, oh, well, of course that doesn't work. But he's trying to fix it so that you could. And the idea is to be able to refer to a capture name in the trailing return type. Currently, they're in completely different scopes because a capture isn't part of the function signature at all. It's part of the body of the lambda. So for it to be referenceable in the trailing return type, in some ways doesn't make sense, but in other ways it's what people would expect to be able to do.
Mm-hmm. I get the idea. Interesting.
Yeah. Okay, well, Klaus, let's start talking about Solid. If you've been programming for a while, you've probably heard of the Solid principles, but you gave a really nice talk at CppCon this past year, going into each of the different Solid principles in some detail. Could you maybe start off by giving us a brief overview of them?
All right, so I hope I don't make this another 1 hour talk, but perhaps brief overview for those who have not heard about them before. So Solid is an abbreviation for 5 design principles. So initially they're pretty old to some extent. Some were formulated in 1988, at least conceptually, but they were put together in 2000 by Robert Martin, who decided that for him personally, these were the 5 most important object-oriented design principles. This is how they are also listed at Wikipedia as object-oriented design principles. He did not call them Solid at this time. I think 4 years later, approximately 2004, Michael Feathers realized that SOLDI could be made into Solid. And so this is where the Solid acronym comes from. So the first letter, this S, is for the single responsibility principle. A principle that essentially tells you that change is important and you should design for change. You should design such that you can change things in one place, that things are changed for one reason also. Then the second letter is for the so-called open-close principle, which is, well, the name does not reveal it so much in this case, which is about how to extend things more easily. You should design such that things are easy to extend in the direction that you want to go. I'm sure we're talking about a couple of examples later.
Sure.
Then the L, the Liskov substitution principle, is a little focused on substitutability. What is a good substitute? How should these substitutes behave in a certain environment? What is expected behavior? Then we have the I, so-called interface segregation principle, the one that people usually tend to forget because it apparently is the least important. From a personal perspective, it is indeed a special case of the first one, but it is focused on interfaces. It tries to decouple interfaces or give advice on how to decouple interfaces. And the last one, the dependency inversion principle, is about steering dependencies the right way so that you can really create proper architectures, proper design where some things depend on other things and not the other way around, if it is the way you want to design it. Okay, the short introduction, the quick walkthrough. So I decided to give it a try at CppCon. I actually have to admit, I did not expect that this talk would be accepted. I was a little, I was expecting that people would say that this is too old, this is known, but a lot of reviewers liked the idea. And so within 60 minutes, tough time frame in this case, I tried to really give examples for all of these 5 principles. Why are they important? Which situations go wrong if you don't adhere to them? Yeah. So I was actually pretty happy that it was accepted. I was actually hoping even that it would be taken for the Back to Basics track. I wanted to make it a beginner-friendly talk, but well, Arthur didn't like it so much apparently. There were so many other talks anyway. Good talks, so yeah.
Arthur's the primary organizer of the Back to the Basics track, huh?
Correct, yeah.
Okay.
He basically tells us which talks go in and which do not. My feeling, probably he's not the only one who has a final say, but
Sure.
Yeah.
You and I both had talks in the 2019 Back to the Basics track, I believe. Okay.
Correct, yeah. I had one other talk in there as well, but the solid talk was extra. Yeah.
I find this just in general, these engineering design kind of principles. When I do training, I have people ask me, "Oh, can you do a class on, basically the kind of thing you're talking about, Klaus?" And I'm like, "No, I can teach you how to understand C++ better. I am not the right person to come and do training about how to design your architecture better."
Oh, this is good to know. Now I have something where I can say, if you need that, ask me. Because I'm truly focusing on the design issues more than on the C++ language issues. So perhaps this is indeed a good combination. They can hire us in sequence. Perfect.
That sounds great, actually. Yeah, let's do that.
So indeed, in a lot of training classes, I talk about Solid too, but then of course, I give a lot more examples on how code should be structured. Design patterns also something I tend to talk about a lot nowadays, and this is where I apply them. What works, what does not work, why does that work and this does not. Very often you can use these solid principles to give them a feeling why something does not work and another solution works better.
Okay, so we're going a little off the plan here. Since you just mentioned design patterns, are they still relevant? Are they relevant to C++? What does the modern programmer need to know about design patterns?
So my personal opinion, of course, is they are relevant and surprisingly relevant. Just perhaps a teaser for the training class. I know you shouldn't do too much teasing, but type erasure is essentially just a combination of 4 classic design patterns. And it works pretty well because all these properties of these design patterns are just combined. Okay. Good ideas combined should give you something even better. I believe it's relevant because of the terminology. First off, you should have an idea what problem you're trying to solve if you're talking about a visitor, if you're talking about an observer, a strategy. And so some people argue this is ancient, this is not needed anymore, but I think this is just again about managing dependencies properly. And this is as necessary as it was 20 years ago, or 25 years ago. So the Golf book was published in 1995.
That's the Gang of Four? That's what you're referring to?
Gang of Four book, yeah.
Yeah. Okay. The classic design patterns book. It's been on my to-do list for, I would say, at least 11 years to read one of the design pattern books, and I have not yet done that.
Okay.
Would you recommend that I still go back and read the classic book, or maybe one of the newer takes on these things? I don't know, Head First Design Patterns, or one of these, lighter weight versions?
Yeah, okay, that's a problem. Lightweight. It's not particularly lightweight. Probably you're pretty bored halfway through. Yes, it's very formal description, and the coding examples, you would not like them. They're totally out of date.
Okay.
There is not a lot of new books, though, that really go through all of them and explain them in this formal way. There's one book by Dimitri Nestruk, who tries to give more modern examples. This may be something that you can choose. It has received mixed reviews on Amazon, so some people like it, some people don't. If you read it, you can, of course, make up your own choice, whether this is something you like. There's a hands-on design patterns book by, and I forgot the name, sorry. Comes up to me in a second. Which is also good, but it's bigger and there's a lot of content that you already know. So language-specific things. But unfortunately, there's not a lot of literature on design patterns anymore. Something that formally introduces them and perhaps uses new examples to, also modern C++ examples to give them a real meaning.
I found the hands-on design patterns book, I think, the C++ one, although I have to say this website that I found it on makes it very difficult to figure out who is the actual author, unfortunately.
Okay, if I turn around, I can get a pictures, of course.
Okay.
Sorry, Fiddle.
And it looks like there's various versions of these. There's the hands-on design patterns with Delphi, which is unlikely to be applicable to most of our listeners, I believe. And then hands-on design patterns with C++ is I'm assuming the one you're referring to.
Correct.
Okay.
Yeah.
Going back to Solid, you mentioned how Robert Martin came up with these like 20 years ago as being for object-oriented programming. Do they only really apply to object-oriented programming, or do they apply to other styles of programming, in your opinion?
In my opinion, and also luckily the opinion of a couple of other people, they're completely paradigm agnostic. So you can use them for object-oriented programming just as well as functional and generic programming, because it's mainly about dependencies. And this is a problem that you have in all kinds of programming. Of course, sometimes it needs a little different explanation how they apply. And that's exactly what I tried in the talk as well. So I usually try to show some object-oriented stuff, the classic stuff that people understand more quickly, and something from the standard library where you can where this principle is applied. So just perhaps as one example, I think I used a copy function, so standard copy, to explain that this is a dependency inverted function too. Of course, it has nothing to do with object-oriented programming. Not really. But the idea that you depend on copy and not copy depends on you is built into this function too by means of the template arguments. So the copy function itself defines the requirements, defines what you have to deliver, and so copy doesn't depend on you, but you depend on copy. Okay. And that's just sound library design, because of course, if you write a library, you cannot depend on somebody else. You want to be independent. You want to be, you want to define your own requirements. So a concept essentially, now C20 terminology, of course.
Right.
It's pretty similar to what a base class is, just with static polymorphism. And so you can work with this just as well as with, base classes, meaning object-oriented programming.
So you mentioned standard copy specifically, but it sounds like those principles apply to all of the standard algorithms?
Absolutely. So just a specific example that I used in the talk. Of course, the entire library is dependency inverted in this way, making it a real library that is standing on its own and that you have to adapt to. And similar examples can be given to all the other principles as well. I have to admit I don't remember exactly what which examples I gave. Copy is one of my simple examples, but you should find various examples of dealing with these principles in the STL2.
Reminds me of a talk David Stone gave at C++ Now 2015, and he also just reiterated some of these concepts in a talk that he gave at my meetup that I have not yet edited and put on YouTube, so you can't go and watch it yet. But the idea sounds like, continuing along those lines of basically, in his worldview, something like a standard container like Vector would have very few functions. It would only have like 4 functions, and the rest of it would be implemented in free functions similar to copy that are decoupled, making it easier to create standard containers than it is today.
I kind of already think I like to talk. I've not seen it, but this is my opinion too. Whereas I don't complain about standard vector. Standard vector is actually fine, although it has 60, 70, I don't know, member functions.
And
Quite
half
a
of
lot.
those are constructors.
Probably, yeah. And there's multiple overloads of begin and end, of course, so everything sums up. But still, I believe standard vector is very much focused on managing a dynamic array with very little functionality that is just convenience. So for instance, pushback is convenience for insert, but with the additional benefit of a different exception safety guarantee. And so there is a very important implementational difference that, of course, is important. So I think this is fine. As a counterexample, standard string probably would not satisfy the single responsibility principle.
Hey,
I
we
don't
got
know.
like 5 more member functions in C++ 20.
And it keeps growing. It has to, because of the interface changes, and it will never change. So standard string comes with everything, all kinds of manipulator functions, substring functions, all kinds of algorithms, find, etc., which of course are a little more convenient than using the SDL algorithms, a little more direct, perhaps some better names. But most of them could indeed be implemented separately outside the class, couple less, be more generic. So this class could be leaner, less coupled. But of course, we cannot change it today anymore. Yeah. And I think this is what David probably talks about too. Probably you can decouple quite aggressively if you really focus on the essential interface, nothing more.
Right.
Okay.
I'm kind of curious what other parts of the standard library break these principles other than string.
Yeah.
Okay, I did not do a detailed analysis. No.
Okay.
I do agree that a standard function could have been leaner, but this is something that, of course, most people nowadays agree to. But no, I did not a detailed analysis of the STL with regard to the solid principles. No.
Yeah, standard function, I think, to be fair to the standards committee, along with standard bind, where they were standardized at a difficult time as we were trying to understand what modern C++ was supposed to look like. What is C++ 11 actually bringing to the table? Like those kinds of questions.
Yeah. Someday probably have potentially have successor, and well, a function 2, or somebody proposed, I heard this recently, a trampoline, because standard function acts like a trampoline, a call to some other function. So I think there's potential to update this eventually.
Yeah, and function view, I think, was probably similar to the trampoline, would sound like a...
Yeah.
What do you think C++ programmers should really make sure they understand with solid principles? Like, if you're new to C++ or new to programming in general, what should you make sure you understand from these?
I think it definitely pays off to get an understanding why they are considered important design principles. As soon as you're starting to write bigger software, and not just a couple of thousand lines of code, but large-scale stuff, you will always have to face the problem of dependencies. You change one thing, everything recompiles. And you want to change one thing, and you have to touch a lot of places. And as soon as you hit these a certain threshold, and I think Jason defined this to be larger than 20,000 lines of code, which is smaller. As soon as you hit this threshold, this suddenly definitely starts to matter. And also starts to matter if you're working in a team and everybody is working only on a subset of things. And so I do think that it pays off to have a pretty good idea of the basic ideas behind Solid. So why is it good to pay attention to the single responsibility principle? Why should concerns be separated? Why should cohesive things go together and other things go separate? Why should I really think hard about an extendable interface? I should think about what do I want to extend in the future and apply this open close principle. So this is why I think this might be valuable. It's not something that you use with every single line that you write. Does this adhere to solid? Does this adhere to OCP? I don't think so. But it's more this feeling of realizing that dependency can hurt you pretty badly. And this is what I see when I do consulting or also training classes or I talk to people. Indeed, the major pain points are things that are too tightly coupled, things that cannot be changed easily anymore, and then they're not documented and badly tested also sometimes. And then, well, people just are not really happy anymore.
Sounds like a great situation. Bunch of tightly coupled spaghetti code, 40,000 line functions that aren't tested.
I've not seen a 40,000 line function yet, but
I can show you one if you would like to see one.
Oh, okay. There's classes that I have this kind of size, yeah.
Actually, no, I'm sorry. I can't show you a 40,000 line. I believe the longest I can show you right now is a 22,000 line function.
Okay, but a factor of 2, what is a factor of 2, right? Eventually, people say, oh, it's large.
It's large, yes. Okay, so say you have this 40,000 line file with a 22,000 line function in it, and basically none of these solid principles have been applied.
Yep.
And feel free to not, to say, well, you have to take my class to get more information, but, how do we get started on trying to fix these problems?
So if it's really a 40,000 line function, it's probably a long and painful process. Probably shouldn't get there in the first place. But usually the advice is to start separating concerns. To really think about why is this function so long? Is it really something that focuses on one issue? And I would slowly but steadily tear these things apart. One of the things that you can likely do in this kind of function is to use RAI a little more often. Very likely this is also dealing with memory management and all these kinds of things. This is why it gets so long. Probably also a lot of error checking, etc. Mm-hmm. If all of this stuff is separated out, separate functions, functionality, perhaps even separate modules, this makes things easier already. And of course, the hardest part is then understanding what are the subparts that I put together. What are the individual functions that I could extract? It definitely isn't an easy job. Oh no, definitely not. Takes some time. Usually, however, it's not these long functions. Very often it's just bugs that you encounter, bugs that sometimes are just based on a misunderstanding. Very often, interestingly, however, the bug, as a source, the bug has somehow mixed responsibilities. Something does two things. I changed one thing in some update and broke something else. Mm. It happens indeed surprisingly often. And then the real fix is not to just change the line of code that broke, but to separate concerns in order to make sure that in the future this kind of problem cannot occur again. The real problem now is that this takes definitely more work, definitely more time, and so probably it's not done right away. This is how these 40,000 line code functions come to exist.
I just need another if case example. Here. It'll be fine.
Yeah, exactly. Yeah.
Yeah.
People follow example. People don't want to invest so much time. Sometimes it's true that they don't have the time, and so things grow instead of things are separated to create new building blocks that they can reuse in a lot of places.
So if someone's going to hire you to come in and do training or consultation, why would you argue that it is worth spending the time to learn these things and to fix the problems the right way today?
Because I'm pretty much convinced that good code is cheap code.
Okay.
Very often people are concerned about time and money. At least management is eventually. And if you spend a little time upfront to keep the quality high, you'll have so much less problems later and will save so much time and money that, well, you will just be so much happier. That's why I definitely feel there's a huge value. In a real life, in a real environment, of course, it's not that easy. I totally admit. But having these things in the back of your mind perhaps helps you to sometimes at least do the right thing.
Sometimes
Even if it's slower. I've seen a lot of things by now.
Okay, so you mentioned several times that you're happier this way. Now, have you actually directly observed this, that developers that are working on the spaghetti code bases are not as satisfied in their job?
I did actually experience this firsthand.
Okay.
So I've worked in a couple of teams by now, and I think there is really a difference. Some people are just, doing their job because they have to. They're not unhappy, but they do know that it's not a perfect situation. And I've seen the other side as well, where people are really investing a lot of time into refactoring and writing tests, and also keeping their developers on a very high C++ level. Yeah, and I feel the atmosphere is just better. People are also much more likely to help each other because they have the time to do so. Mm. It's a more lively group, more lively interaction between people. Which, sorry.
Do you ever run into any misconceptions that programmers might have, or hesitant to start, spending the time and investing in learning and applying these design principles?
Oh, there is indeed a couple of misconceptions. The first thing that I think the hardest of these 5 principles is the first one, the single responsibility principle. Because commonly this is understood as, everything should have one responsibility, and even simplified, everything should do just one thing. And it is really hard to apply to anything. What is doing one thing? What does this truly mean? Does standard vector do one thing? Yes or no? I really couldn't answer because I don't know what this one thing is. And if you really think along these lines, it really is very hard to apply. If you think about change a little more, this is what I try to also show in this talk. If you try to think about why would I change this? What does this represent? Suddenly becomes easier. Easy to apply, easy to reason about. And so, as I said, standard vector represents everything that you need to manage a dynamic piece of memory, a dynamic array. Standard string represents something similar and a lot more things that you can do, a lot of more operations. Also, is a function that does something and does logging, is this okay or is it not? Because it does 2 things. Well, it is okay as long as this one function does not implement all the details for logging, etc. If this is just using other functionality, the responsibility, that the task of this function is just to draw these things together to create something bigger. That is reasonable. You would only change it if you wanted to change the sequence of operations, for instance. That is, I think, something that keeps people from really getting the value of this single responsibility principle. I've seen a talk, I can mention a talk by Kevlin Henney, who really tried in his talk to destroy the solid principles, except for the first one, the single responsibility principle, because he did not really believe in interpreted them differently and argued that this doesn't make sense. Okay, my opinion is they definitely do make sense, especially since he's referring very to the first formulation of these principles, and I believe since then they have evolved, and you now find them to be much wider in applicability. So, okay, my personal opinion.
Okay.
Then some people just feel they're old. not necessary anymore. This is something that, of course, you can understand. But as I said, dependencies is something that is virtually present everywhere. So I don't think they grow old. Yeah. And also, the other thing that is hard to understand is this dependency inversion principle. The fact that I really want to turn around dependencies is very, very often just explained by introducing some kind of abstraction. Very often it's just explained by, well, let's introduce a base class, and then we have inverted dependencies. What is often not taken into account is the fact that you also need to assign the responsibility for this abstraction somehow, properly. And I've seen this fail, so some modularization of code, people introduced the abstractions, but on the wrong side. And to them, it always felt wrong. And when we talked about this, they realized, oh, if you put them on the other side, suddenly it might actually work. So the dependency inversion principle is probably also hard to understand. So SRP is probably harder to apply if you imagine the wrong thing, and the dependency inversion principle is probably harder to understand. Yeah, but oh, okay, sorry.
No, I'm just thinking like through, because yeah, I'm having a hard time thinking. Okay, I believe I have experienced what you're describing when you're looking at a problem and you say, oh, this is really, really hard to implement. It doesn't make sense. But then if you manage to invert your thinking and say, oh no, wait a minute, I'm looking at this from the wrong direction. Like if I understood correctly, you're saying people try to do, yeah, the dependency inversion principle. Anyhow, I'm just thinking through these things also and wondering, when you do a class, do your students like bring examples and say, though, this is the kind of problem that we've been trying to solve, so that you can do direct examples with them?
Sometimes, not always. It depends on the class, but if I'm in a company, this indeed happens. Because if I'm talking about something, sometimes they realize, oh, you have something similar, could we talk about that? And I feel this is the best thing that could happen, because using a concrete example is really helping them in their specific, with a specific problem. Else we remain a little too abstract, and perhaps we are not really communicating on the same page. So right. Examples are great.
Okay.
So perhaps allow me to give you another example for this dependency inversion principle.
Sure.
So you might be aware of the model view controller architectural design pattern. And a model, so I am now using the Wikipedia version where the model is in the center and you have controllers and views that communicate with this model. Architecturally, the goal is that the model is independent. That model is the one thing that does not depend on either the kind of control, so the thing that gives you some command, and the kinds of views. And I think views is easier to understand. So you want to represent the result via HTML, via some graphics library, different ways. The model, of course, should not depend on how you want to represent the result. Mm-hmm. Of course not. And this is why the model itself should define the abstraction, how it passes information over, which kind of structs, data sets or whatever. And the view has to just take what it is given. So the model is in command of the abstraction. By that, it is not depending on the view. And this is why I've inverted the dependency. The flow of information is from the model to the view, but the view depends on the model. So it's kind of the different direction. Okay. I don't know. This is usually where people start nodding like you just do and say, okay, I have to look this up later. Think this through later. It is a little harder, but really relevant if you want to decouple properly.
So, but you are saying that the model view controller example is a proper example of dependency inversion?
It is. If you implement it correctly, it is a good example indeed. Yeah, so if the model is in control of the abstraction, this is a dependency inversion, and you have something that you can build on. Anybody could now add a view, and a model would not realize it, would not depend on it.
Right.
Now that's the ultimate goal, of course, extensibility by means of, well, let's call them plugins.
So do you ever see people doing what, at least what I'm inferring from what you're saying right now, would be going too far and making a generic viewer that can work with any kind of model abstraction, and then they end up with, overly generic code and overly generic abstractions?
So I cannot argue if it's overly generic or not. If you have all the information at compile time, go for it. Perfect. You don't need a runtime abstraction. You just pay attention to the same problem. So the model should not depend on any kind of view. Mm-hmm. If you achieve that, even by static polymorphism, perfect.
Okay.
So perhaps you can use what Andrea Alexandrescu suggested in his Modern C++ Design. So the book that was published in 2001, this policy-based design, this would be a template-based approach, which just works as well.
Right.
Yeah.
You mentioned that Kevin Henny talk where he argues against the SRP principle.
He argues against solid. He does like SRP though.
Oh, he likes SRP, doesn't like the rest of solid. Okay.
Yeah, correct. So he completely objects OCP. He kind of argues that LSP, so that list of substitution principle, doesn't make sense if you really read the original publication and the original terms that are used. He feels like I do that the interface segregation principle is kind of the same as SRP. I agree here. I think it's just a very important special case, so why not mention it explicitly? And I think he also comes to the conclusion that dependency inversion is nothing but single responsibility principle. This is where I feel a little different, though. Okay.
I'll have to see if I can find that talk, maybe put that one in the show notes. But I was wondering if you're aware of any other arguments against the solid principles, or if there's any like newer design patterns that are competing with them or anything like that.
Unfortunately, no. So in this particular case, I have to say unfortunately, because it would be great if there would be other things. It would be great if we would have more design principles. This is, to my best knowledge, this is the best we have still. And probably this is why I still try to talk about them, or why I do talk about them. Because I am not aware of anything better. This is perhaps also why I feel that arguing against them is not really helping. If you argue against them, you should propose something better, because there's so little else.
I see an opportunity here for you, Klaus.
I thought about this, but no, I didn't come up with anything better.
You can come up with something. You just have to repackage it, right? So people who have an opposition to solid, you'd be like, no, I don't teach solid, I teach liquid or whatever. And it's basically the same thing, right? Just in a different order with a couple of C++ isms and maybe some design patterns thrown in. But I'm being half serious, and well, maybe 3/4 serious, because you clearly have the experience and the background knowledge to package this in a way that makes more sense to the modern C++ developer than going back to a 20-year-old principles or whatever.
Okay. I would feel a little bad though if I just relabel kind of. Yeah, so,
don't relabel. It's a modernization of the techniques. Yeah. Don't just relabel. Yeah. I'm not saying steal. I'm saying derive.
Yeah. Yeah, probably it's more deriving, being more specific, perhaps giving it better names. I think it's a naming problem also. Yeah, names are hard.
Right. Names are hard. And if you need to drop one of them because it's a duplicate, then...
Yeah, for instance. Yeah.
Yeah.
A single responsibility principle, the name could be improved, and then we can perhaps integrate this interface segregation into that. Then we only have 4. People like 4 better than 5, probably. Okay, I see this could be something.
Yeah.
Next year.
So your CppCon 2021 talk, it'll be modern C++ architecture with whatever your new acronym is.
Yeah, I have to find a catchy one. That's a problem.
I have to find a catchy one. There's a bunch of four-letter words. I'm assuming you're looking for an English word. We have plenty of four-letter words, although a lot of them you don't want to use.
That is true. And a lot of them have been taken by C++ already. You might have seen Arthur O'Dwyer's list of acronyms, and I was really impressed on what acronyms we already have in C++. Really funny.
Okay.
Okay, now I have something to do.
Yeah, definitely have some homework.
Yeah.
Okay. Is there anything else you want to go over today, Klaus, before we let you go? You mentioned that you do training on these design principles. Are you giving any classes in the near future, or is this something where companies should just reach out to you?
So I will do a training in June, which has already been publicly announced on the Meeting C++ page. It is actually about design patterns, a 3-day class called Modern C++ Design Patterns. The focus of this class is to go over, well, not all the Gov principles, but an important selection of them, but also now definitely showing how to implement them properly. Yeah, not these 20-year-old code, but how do we do it today? There is a couple of very big differences that I know people like usually. I'll also explain type ratio, for instance. I'll explain why it is just a very clever combination of type classic design patterns. And I actually also hope that I can do the course again at CppCon. So I've done this the last 2 years and turned out to be pretty successful. Yeah, so I definitely hope that this is going to happen again.
So for our listeners who are curious, what about time zones for that Meeting C++ announced or that training?
So it's probably in the Central European time zone, so 9 to 5 p.m. Of course, if a couple of people from different time zones join up, sign up, we probably could shift that. That shouldn't be a problem. But it would be hard if people from India and the US would like to join. That would be hard. But this is one of the big advantages of these online trainings. This is why I do like them. Everybody can join. Yeah, in my CppCon training last year, I had people from Argentina, from Canada, and I believe some Eastern European country, which is a little more east than Germany, but a pretty outspread number of people. I should, by the way, before I forget, else Phil might be mad at me. I also hopefully give a workshop again at C++ on C, of course. Yeah, one of the most important workshops I do every year. I've given it once last year, and this also turned out to be a pretty successful workshop.
Has there been the dates announced for C++ on C 2021 yet?
Not yet, unfortunately.
Oh, okay.
I've asked Phil a couple of days ago. I think he will announce something soon, but it's not official yet.
Okay, I was just going to feel bad if we had missed that. We try to stay on top of these things.
Yeah.
No. So the last post on this webpage was in December last year.
Right.
All right. Well, it's great having you on the show again today, Klaus.
Thank you very much for having me. It was a pleasure.
We'll make sure we have links to all of those things on the website.
Awesome.
All right.
Thanks.
Well, thank you.